And without any further ado, it is my pleasure to introduce to you Milen Genchev, who is a customer engineer at Google Cloud. He will talk to us about generative AI, unlocking the power of machine learning. Please join me in giving a warm Armenian welcome to Milen Genchev. Welcome to the stage.
That's a nice picture. So, hello everybody. As already was presented, I'm Milen Genchev. I'm normally based in Bulgaria, and I'm really happy to be here in Armenia. It's my first time. I'm very excited. So, what we are going to do in the next around 40-45 minutes is we're going to do a little bit basics. There will be, let's say, not new things for most of you, but might be new things for you. We're going to the history of artificial intelligence and how we got to the point today. And then I'm going to share, of course, some Google Cloud contributions, some Google Cloud products, and I'm going to present to you some actual use cases that you can use in your business. So, first, okay. Artificial intelligence and generative AI. So what it stands for? Artificial intelligence as a concept, as a term, is nothing new. It was developed in the 50s. It refers to basically a system that requires human-like intelligence in order to produce its outputs or what it is doing. But building applications based on traditional artificial intelligence, it was a hideous job. So we had to code every single function with its inputs, outputs in a standard programming languages. So that's why along the way, machine learning was introduced. And machine learning is basically a method to work with artificial intelligence and to not require actually coding of every single aspect, but to provide the data and the model to be trained by itself. And this was still a very enormous task for you to do. That's why around 2010, we have seen the introduction of multi-layer neural networks. And a neural network is basically how it functions our brain. We have neurons which contain the data, and we have connections between those neurons, which are presenting how that data will be interconnected and output out of the models. With that said, even I can share one early example. Google Search is actually a good early example of how neural networks are actually working and how those algorithms were put into a good use. Another way to present the same topic is actually what I mentioned. I mean, how those things were trained. As you can see, in traditional programming, you had to define every function, every input, output to the function, it was predictable. With the wave of neural networks, we're able to provide structured data to the model. In that particular example are images, labeled images. For example, this is a cat, this is a dog, this is a cat, this is a dog. And then providing to the model a picture which was not seen before of a cat, and the model will output, yes, this is a cat, based on the training data. Coming to today's advancements, or the generative AI age, or in other words, the age of transformers, with transformer architecture, you are able to provide not only structured data, but also unstructured and semi-structured data that you provide to the model, you train your model, and basically afterwards, with the amount of billions and billions of parameters of those models, you are getting an actual summarized or new and novel content that is produced from the model itself. And why this is important? It's important because we unlock many and new potential use cases of the artificial intelligence in, let's say, in the particular case, machine learning, deep learning, and then generative AI. So with that, let's answer to a question, what is a generative AI? So apparently, generative AI is also a broad concept. And basically, it refers to any model. Of course, in the latest years, we're speaking about transformer models, but doesn't require to be explicit transformer models. any model that actually generates new and novel content. So as long as we are, let's say, providing our output and we are getting, let's say, the output to generate, this is how we call generative AI. So couple of things out of that. So you can still have a transformer architecture model which is not generative in nature. So they're used for data classification, data regression. Data regression is something that you see every day in the weather forecast, basically taking a lot of different data inputs and based on those data inputs predicting if the weather tomorrow will be sunny or cloudy, etc. So, and I'm going to spend a little bit more time later on the different use cases. That's why I would like to close here. But just in summary, generative AI, broader concept, the same as AI. Generative AI refers to a model that generates new and novel content. And we also can have models which are not generative in nature, but they're still based on the transformer architecture which all the large language models today are built on, or most of them. Next slide. Doesn't work. Okay? So let's look a little bit into what are the contributions from Google for the recent advancements. And their contributions on that far earlier than 2017, but I picked, let's say, a recent example. And I'll mention some, I wouldn't mention all of them. So transformers. Transformers is basically a new architecture of machine learning models that was developed, that was presented to the world 2017. It was a research paper by Google Research. And transformer architecture is, let's say, simplifying multiple things and improving on multiple things. And I won't spend the time of referring to all of them, I will mention some. The first and foremost is actually attending or applying that attention mechanism to the input itself. When the model attends to its input, it starts to understand the relationship between the words of the input, so it actually understands what the input is about. And why this is important is because when we're doing the decoding function, when we're looking at the output, the model and knowing what the input is ensuring that the output function is in the meaning, or semantically speaking, is the meaning of the input question that was asked. So this is one of the, let's say, greater advancement of transformer architecture. Another one was really around the multi-headed attention. Multi-headed attention is a concept basically where, and I won't explain the details, but what was important about the multi-headed attention that you will be able to train those models on distributed basically compute, and you were able to train those models in a fraction of the time of the previous iteration, which was RNNs, or recurrent neural networks. So, and I won't go into all that, I mean, contribution, etc. I'm going to mention one more. This is AlphaFold. AlphaFold is one of my favorite because this is an open source model that was published 2021 and is basically helping scientists and medical researchers to predict protein folding. So basically shortening the time for medicine and vaccine research by a significant amount. Okay, and yeah, recent years, let's move to the use case. So what I shared so far, I mentioned I went to the history of artificial intelligence. I have shared basically how transformers helped with the evolution that we see today, and of course I mentioned some Google contributions. But let's go to, let's say, a little bit more practical aspect of those models. So basically what we are using those models for and what those models are good for. And I wouldn't be presenting the use cases from a business perspective because we are all building different business solutions, etc. I'm going to look at from technical capabilities of those models. And when I'm referring to those models, I'm referring to transformer architecture models, which are both generative and not non-generative in nature. So, okay. So what we have here, a couple of my favorite use cases, and some which are, let's say, not yet fully developed. First, generation. We all know that. This is what these models are made for, generating video, generating images, generating text, and even synthetic data that you might need. The colleague from Microsoft presented earlier, you might need data that is synthesized for you to do some extra predictions of the lost data that you had before. Then moving to summarization, this is probably my favorite use case and the one which I'm using most by myself. This is taking a corpus of data, and I'll give you an example, a file which is 120 pages long, and basically running it to those models and ask the model to output, for example, 5-6 sentences so you can understand what is this about. And when we're referring summarization, we're not only referring to text summarization. We are now of the age where video summarization will be adopted use case, and at least for me personally, that's great because I don't want to have to watch, let's say, 20-minute video anymore and watch quite a lot of advertisements in between. Just get the essence of what that video was about. Data extraction is all about again, providing large amount of data, selecting which data you'd require. For example, in that case, you don't really need a generative model for it, and then getting just the essence of the data that is expected. And I'll give you one great use case here. For example, you are having a large retail business, and you would like to go and check which was the best-selling good for yesterday. Instead of going to your ML team, asking them to create your data analytics query or whatsoever, you just converse with the model and say, okay, I want, let's say, what was the best-selling t-shirt for yesterday in this country. Voila, you are getting your results. Some companies that are actually doing that, I believe IKEA, I don't know if it really is it. If it's not, forget me saying it. But some of those companies are actually working towards building production-ready products based on extraction principles. Then writing or rephrasing. So for us, for me, it's perfect. And some of the use cases were presented earlier. Just when you write something, you would like to, let's say, make it softer, make it sound harsher. You just turn it to the model, you get your output. Another great use case, and one which as developers you might appreciate, is actually writing the language of your code. If, for example, you have your code in basically Java and you would like to write it on Python, there are nowadays models, not really great yet, but we'll get there, that you can input your code and say, okay, this code I would like to have it in Python. And it won't get you production-ready code yet, but you're going to get a great draft. Then you can actually argument, check, and actually use later on. So, and I'll jump a little bit faster to the others on the screen. I don't want to dig too much here, but semantic search, this is big. Semantic search is, as I mentioned, what a Google search engine was using in the past. In order for you to build in semantic search within your AI applications, you're basically using vector embeddings, you're running embeddings models, you're running your embeddings models, you're then getting a vector representation of your data, and then when you're basically querying, using like vertex matching engine, you are getting, let's say, the results that are semantically similar to your input. So that's important because you can actually use your data to then provide the data back to a generative model that will generate a summary. And I'm going to show you a little bit more on that later. Okay, so those are the use cases on a, let's say, a wider specifically Google focused way. So next, what I would like to move our attention on, what we as Google and Google Cloud, we actually, what we have actually built and what we're actually building especially for AI practitioners and developers. Okay, so that's all of it. Let me explain a little bit more in details. So I'll start top to bottom this time. So first, what we're having at Google, it's actually our purposely built, purposely designed, and purposely built chip for machine learning workloads. And this is not something new. It hasn't bought in the last year. The first version of TPUs, or tensor processing units, was released 2016. Since 2016, we have multiple iteration of TPUs, and we're using TPUs to exclusively train our own models. And our customers are using TPUs to train their ML models. What this is enabling us, first, to have larger quantities of those chips, and secondly, to ensure that all the security, all the performance, computation in parallel, etc., is there for the workloads that will be running, and basically everything that you see on top. Then, if you ask me what Google is doing in the space of generative AI, I will answer two things. One is tools or platforms for AI practitioners and developers, and the second are models. So currently we have released at least 3 model families. They are not 3 models, but 3 model families, different sizes, different use cases, different training data. And they are currently used for various purposes like text, chat, code, image. We are starting with video, and we are going to release something for music as well. Okay. But you're probably asking yourself what's different? You can have the models, you can have your API, and you're working with those models. What we're introducing basically on top, and it's not something new, it's actually the platform that we're using for many years. I believe 2021 was released for any machine learning workloads, and this is Vertex. And because next on the list, I'm going to spend some time on Vertex, I'm going to spend some time on Generative App Builder, which is exactly tailored for developers. I'm going to just glance to what is on top of the stack. So on top, we are having consumer-ready products or business-ready products, which you can basically use without knowing any coding, any development, anything of the sort. Some of them are old products, like Document AI. It's not something new. We're just enhancing now with the power of generative capabilities. Discovery AI, not something new either. It is just being enhanced with generative models. And then we're building some new products, which is Duet AI for Workspace, something that you can have as your assistant inside Google Workspace to write your emails, answer to your queries, etc., etc. And the same for Google Cloud. Okay. So that's basically on our portfolio. Let me point your attention now to Vertex and why, in my humble opinion, Vertex is a great platform for you to use. So first, I'm not going to go to that whole slide, pretty busy slide. I'm going to focus on a couple of aspects which are directly related with generative AI. And let me make a step back and explain a little bit what Vertex is about. As I mentioned, it's a machine learning platform. It's not only for generative AI purposes. It was built for machine learning and your machine learning workloads, open source models that you can use, etc., etc. And you have multitude of instruments with which you can work with both generative models or foundational models, as we call them, and your own machine learning models, which you actually can build in the traditional way, so planning, doing the scientific research, doing all the calculation by yourself, etc., or you can use with no-code and low-code workflows, which is AutoML. And basically, I won't spend much time on AutoML, but see it like you are providing still a large corpus of data, you are defining the rules or the outputs that you would like to experience, and then all the training, all the, let's say, all the calculations for the model are done inside AutoML. So what you're getting at the end, you're having a machine learning model which is tailored for your needs. A few other things which are going to go into details. We're going to look into the model garden, Generative AI Studio, and Workbench, which Workbench is actually the place where you can use as developers to develop AI applications, to integrate basically models in your existing applications. Okay, so that's on Vertex. So few really good things inside Vertex that you can use for the purpose of generative AI workloads. First is the model garden. It's a little bit vague as a text, but basically what model garden is, as the name explained, it is a place for all the Google foundational models as well as all the open source models that are currently available on the market. And what you can actually do out of it, you can create a solution which is based not on a single model, but you can base a solution which is based on all that is available within the model garden. Some of them, and every single model, it is also priced differently. The open source models, the only thing that you are paying is the compute and storage on which is actually running. Then, let's say you selected your models. You decided, okay, those are the 3 models that I'm going to use. Next, you would like to actually do a rapid prototyping. So for that, inside Vertex, you have Generative AI Studio, which is exactly what I mentioned is. It is an instrument that you can use for testing your prompts, designing your prompts, engineering your prompts, and also perform tuning jobs on those foundational models. What is important, and this is a little bit on the commercial side, but what is important, a lot of customers are telling me that this is great for them. We're charging exactly the same price if you're inferencing the model directly, or if you're inferencing the tuned model by yourself. So the price is the same. Okay, so next we tested our model, we played with the different, let's say, parameters, with the temperature, top P, top K, etc., etc. We found our perfect balance between creativity and, let's say, fact-based answers, and we would like to basically move forward. So what we're doing next? Okay, this one I forgot I'm having here. So before we go to that, I would like to explain a little bit more of how the whole tuning activity or the whole tuning exercise is done within Vertex. So first, you are having your data. It is stored within your compartment. You are the only one who has access to it, and you have the model for which you can, the model that you would like to tune based on your data. So the way it goes, your data needs to be structured at the moment. In the future, we plan to look into unstructured data tuning. And you're providing basically the examples which are representing your business case or your business specifics, and you're providing those to the models. You are providing those to the models to a tuning job. So what exactly is happening? We're running Vertex pipelines. Vertex pipelines is an end-to-end orchestration. Then out of it, the output of Vertex pipelines is an adaptive layer. And for those that might not know what adaptive layer is, this is a neural network, a single layer neural network. It's a feed-forward neural network that actually changes the weights between the individual neurons inside your network based on the tuning data. And the greatest thing out of it is actually not making any changes to the foundational model, which is making it fast and cheap. So what we're doing next, we are taking the adapter layer, we are coupling that with the foundational model for which the tuning job was run, and you are creating an endpoint. So endpoints, you can have multiple endpoints, and basically, I mean, at the end you can use API queries, and you can use directly calling of those endpoints, etc. So at the end, when your users are actually inferencing your model, they are inferencing the endpoint, then is a combination of the adaptive layer as well as the underlying model. Okay. And why I squeezed this particular slide for tuning and adaptive layers, etc. It was because what is important to be distinguished between end consumer solutions and enterprise solutions is basically the protection of the data that you have. So any data that you're using for prompt engineering, prompt design, for your vector databases, for any data that is not publicly available, it is actually stored within your own GCP compartment. So in other words, it is your data, and Google does not have access to it. Google is not using it to train your model, to train any of our models, to do it for any purposes which are just serving your needs. And you can actually go to greater lengths of actually uploading your own encryption keys to protect your data. And with that, there is even no theoretical possibility that that data will be used for any of those purposes. So, and adaptive layers is one of those critical data points, which is, as I mentioned, stored within your own compartment. And two additional ones are the data that you generated for the means of enterprise search and conversational AI. And we are going to spend some time on it later. Okay. Okay. Oh boy, that is quite cute. So before we close with Vertex, and so let me make a summary. So far I presented Vertex to you. It is a platform for machine learning workloads. We have looked into the specific generative AI use cases inside Vertex. We have looked into Model Garden, Generative AI Studio, pipelines, tuning jobs, etc. And the final piece, which developers are interested into, this is Vertex Workbench. And what Workbench actually is, it is your place for your code development. You are using your access controls, you're using your security, you can share those notebooks that are being loaded. And it's simple as creating a new notebook, which is actually a machine, which you can tweak based on your requirements with sizes, etc. It is an environment that you would like to use. In that case, it's a TensorFlow environment. And then you upload your code. And the beauty out of it is you might have developed, for example, a lot of things on LangChain. And LangChain is a widely spread framework for wrapping of, for working with different models and for doing different things with those models. And basically what you can do, you can upload your code inside Workbench and then execute your code in Vertex. So it doesn't exactly need to be calls inside Google models. It doesn't need to be exactly let's say, open source or foundational models. You can make external calls to APIs as well. So if at the end of the day you would like to build a hybrid solution, you can actually mix and match the different approaches. You can use all the available open source frameworks there and just load everything inside Vertex. And don't really care about the resilience because it comes with the SLA and nothing will ever stop working. Okay, so we spoke a lot about Vertex. Let me look into a demo. Unfortunately, we won't be able to make it live, but what I did is actually I spent some time into making this demo offline, and here it is. So Generative App Builder, as I mentioned, it is tailored for developers. It is really for individuals that does not want to get into the deep, into the depths of artificial intelligence, don't want to tune models, don't want to do parameter efficient tuning or any of those tasks. So the first, let's say, engine, if you would, the first engine that I would like to present to you, it's the search engine. And what the search engine actually is, it is a semantic search engine. You're basically having your data, you're ingesting your data. Once that data is ingested, it is running to embedding model, your vector database is being created. And then when you're doing a search, the first activity out of, let's say, the first activity that is being conducted is doing a semantic search towards that vector database. And before I go to the results, let me share with you how easy it is. So you go here, you select an engine, you select that this will be a search engine, then you select your data source. You can select from a website, unstructured data, or structured data. This is where I mentioned that those use cases with the dynamically created data analytical queries for the most sold, for example, t-shirts yesterday. Then, of course, you're selecting the data store name, and then you have your engine, and it's that easy. Okay, let me make a caveat. If you are actually ingesting a website with 7,000 pages, you have to wait for the indexing to go, and it will take some hours. But if you are ingesting, as I was planning to do on stage, PDF documents, in that case, those are like 20 PDF documents, which are all research papers, 120 pages. This happens for around a couple of minutes. And what's the result? So you have the option to preview what the results looks like. You are having, based on your question, which I did explain transformer architecture in a few sentences. So it gave me all the documents that actually was used to answer this question. As you can see, one of the documents is attention is all you need, the research paper that was foundational for transformer architecture. And then you got a summary, which is not exactly correct, to be honest, because it was not only one person that created this sentence, but actually the output is quite on what exactly transformer is. And if you want to read more, you scroll, you go to a document, it gives you where exactly on which page that information is, and you're ready. So then, let's say you like the results. You say, okay, this is something which my users, my internal team will be happy about. What I do next? Okay, this is another preview. What I wanted to show here is actually that you can ask follow-up questions. You asked about transformers, then the next question is around a specific topic on transformers. Here is self-attention. And the first time I asked the question, it gave me with all the vector representations and all the details. That's why I asked a follow-up question, can you give me less technical terms? So everything is ready, you like the results, you manage to your data, you manage to the amount of, let's say, results that you use for summary. I would like to move it into production. And this is definitely an older version of my presentation because my data store was, let's say, was not shown. No worries, I'm going to remove it after the presentation. But what is here? You have your integration. You can actually do both widget API, if you like to API calls that are, let's say, triggered from your application itself, or you can just put it on a website. For the demo, I just allowed public access, and I just gave the domains that were able to call basically this widget. And that's it. I mean, you ingest your data, you, let's say, change some of the parameters, you test your engine, and then you put it into production. Okay. So what comes next? Let's make it a little bit more complex as a solution. So what I showed you before, it was end user, querying enterprise search. Enterprise search is querying vertex, specifically it's querying vertex matching engine. Now let's put dialog flow into the middle. So dialog flow, it's also not a new product. Dialog flow was developed 2020, I believe, and it was used by many, many companies for intent-based conversations. So it was again machine learning concept. You're still matching the question to what is in the vector database, but then the actual price was based on, if you would, if-else scenario. If there is a matching, this is the apply. What we're doing today, we're saying like that, okay, we still like to keep the intent matching, but let's say we have no intents. And if there is no matching, go directly to enterprise search to basically search within the vector database behind enterprise search. And if you find results, if you actually find those results, then summarize those results by sending them to the model and provide them as an output. And as you can see here on the demo, basically the data source was the Google Store, and this model was able to answer questions from the Google Store itself. However, what is important is behind actually all that, there is a bit more to it. We also use like retrieval augmentation as well as React frameworks to ensure that the answers are actually fact-grounded into the input data. So in other words, if the model does not find information into the input data, it won't return any reply. And I'm going to show that in a minute as well. So how that solution actually works. Okay, here is what I wanted to show you. If we're using the first approach, which I just explained, when you ask him a question which is not found into the vector database, it won't answer. I missed that, what was that, etc. So the user won't receive answer. So with that, you actually ensure that the conversation between the end user and the model is controlled. The model won't start, let's say, speaking or referring to any competitors or any information that was not found in your database in general. But still, because we also have use cases where we would like to get those answers, we still have implemented methods of actually doing that. And basically using exactly a well-defined prompt that is defined by yourself, and just shooting it to the model. So if we're using, let's say, the first approach, we're getting that results. But if we're using one of the other options, we're actually getting a reply by the model. So why that is important? So basically what I would like to show you here is that Google, by integrating multiple systems, multiple products that we have not, let's say, from the last year, we actually are able to build based on those systems end-to-end solutions. And what I just showed you, I mean the combination of vector databases, generators, prompts, etc., it's with this high-level architecture. So there's much more just to it, but this is what I can show. So basically what is happening when your user is conversing with the agents, it is first going to dialog flow. It is determining which path this conversation will go. It will go to enterprise search, make the semantic search, it will apply in a summarized fashion, and this is what we call knowledge base or infobot. Let's imagine, however, that you would like to pull some data. You would like to pull some data for that specific user, and that data is found within your CRM system. With that, you can actually trigger intent-based, and we'll now be introducing instruction-based flows, which will actually collect all that data for that particular user, and then it will create a prompt that is sent to the model itself. This is a use case. So for that particular user with his details, etc., etc. Or it might take that data, still store it within the database, but decide, because your workload, it will decide to actually go into the knowledge database, and then on the next question to answer from the data for the user. So what I'm trying to say with many words is you can use that solution, and it's, as I mentioned, end-to-end solution. It is built in a matter of minutes, and then you spend way more to actually, let's say, integrate those additional components into the direct workforce solution. You can use it in many different scenarios. So, long story short, why I'm showing you this is to show you the integration capabilities between your backend systems, between, let's say, your analytical queries. You can also use it to gain insights out of it. And what insight is in that context? Let's imagine you have created a virtual agent. That virtual agent is conversing with the user, but at some point the user say, okay, you're not helping me, please transfer me to a live agent. And then that information, that conversation between the user and the live agent, you'll be able to see in insights, and then you'll be able to use that data to put into your data store for the next use. So you're closing the full circle between your end users and the virtual agent. So if done correctly, after a time, the amount of conversations that are handled by the end user, by the real agents will be decreased, and the amount of conversations done by the virtual agent will be increased. So that's more or less everything that I wanted to present to you today. Let me just double check. Yep, we presented that. Okay, this is just another scenario, another possible solution. In that case, we're actually implementing document AI to go to the documents, to generate knowledge graphs, etc. And you're doing a very same scenario, enterprise search, vertex, and then an end solution. So the reason for me showing all those slides is that the options are limitless. With generative AI, we are now at the age where we start to understand what can be really done with the technology, and we are already at the stage where we understand that it cannot be just done with a single model, and we have to build those solutions. And you, as the developers, you are the ones to build the solutions. Thank you.
Thank you very much, Milen. A very deep dive indeed. And as usual, we will entertain a question and answer period now. So as soon as you see the QR code, you can go ahead and submit your questions, and we will get Milen to answer them. Thank you so much for sharing, Milen. Let's give the audience 2 minutes. Never mind, we are good to go. Ready for the first question, Milen? Ready for a question?
Yes.
Okay,
yes.
beautiful.
Let's go.
All right. Generative models work fantastic in English. What is your vision at Google of Gen AI development for low resource languages like Armenian, Icelandic, Estonian, etc.?
Sashka, can you repeat
Of course.
or probably give me?
Yeah, I know it's not very audible from here. It keeps changing. Generative AI for language question.
Oh, super. I like this language, this question. So basically, those models are not only trained on data corpus that is in English. So actually, it is proven, and there is a scientific paper on it, that when you're training the models on magnitude of languages, then even the performance on an individual language is actually increased. And as you can imagine, English is quite polluted language because many nations are speaking it, many different pronunciations, etc., etc. And I often find that different languages are even giving better factual results when you're actually using them. And a good, a good proof of concept or a demo, you can just go to the public version of those models, which is Google Bard, and you can actually converse on multiple languages with Google Bard and you get an actual results. Should I just...
Yeah, you can choose whatever you want, or I can choose for you. We have a voting system, so whatever you see on top is the most popular.
Super.
Go ahead.
Can we use this for test and learn purposes for free, or is paid only? Okay, so there are two aspects of this question. First, Google, as a company, has already released multiple products which are free for consumers. So this is Bard, this is MakerSuite, which MakerSuite, in reality, it's a very tiny version of Vertex, if you look at it from that perspective, but you can use it for testing, prototyping your ideas. Also, since Google definitely would like to help everybody to utilize generative AI, when you go to Google Cloud, for every single of those products, you're actually having amounts of credits which are free for you. Different products have different amount of credits. But basically, they're enough to earn you for a couple of months, to be honest. Assuming that you're not doing in production, you're not doing many queries, you're just doing it for testing purposes. So to answer this question, yes, definitely. And if you have a good idea, you can always contact me and we can find ways for even more credits. So how to estimate the cost on a Google Cloud early in the process before you invest a lot of time in configuration. So a way to do that is we're charging, let me put it this way. Different products have a different charging structure. But what is in common is that we're charging either on character, and we have provided guys, for example, how much characters a particular, let's say, use case, those technical use cases, it's normally having. So this is one way to predict. Another way is if we're looking at enterprise search and let's say conversational AI, it is charged by dialogues. So you can say, okay, I'm planning to have this amount of dialogues, this amount of back and forth communication, and you can actually calculate that. And I believe, don't quote me on that, but all the pricing or a large portion of the pricing is now in the Google pricing calculator. So you can go there, you can put your numbers, and you can get an estimate how this looks like. It is possible to train a model in one language, English, yes, and use with another one, Armenian. Yes, but you need to then run a translation model, let's say in between. So for example, so the general answer is yes, it can be achieved. It is not available out of the box. If you would like to use, for example, enterprise search with Armenian, you just provide your input data in Armenian language. I mean, I'm not really 100% certain if Armenian it's fully supported, but I have found it quite useful for many of the languages which officially was not supported. You're just getting your results back. But to the question, if you would like to do the training in English and then have everything translated to Armenian, yes, you can do that. You just need to plug in, let's say you develop your workbook, you need to plug in translation in between. And you can do the translation with Google Translate, T5s, etc., so whatever you have.
Milen, forgive me for interrupting. We did run out of time for the Q&A.
Okay.
Yeah.
Okay.
So thank you so much, ladies and gentlemen. Please join me and thank you, Milen Genchev, for sharing his ideas. Thank you so much.
I can actually answer all those offline.